Before we get into the example, I've been wondering. Fusion has a lot of cards, one for detection, one for signals, one for turnouts. Why so many?
Because the Fusion design works best when every card does one job really well. Detection uses analog electronics. Signals use PWM. Turnouts use motor drivers. Mixing all that onto one big board gets messy fast. Complicating expansion and HW changes for fixes, enhancements, and upgrades.
So everything gets its own specialist?
Exactly. Wiring is simpler, troubleshooting is simpler, and hardware or firmware upgrades only affect the card being improved, not the whole system. Fusion learned this early on. The modular approach grew out of necessity as the project expanded.
Got it. Keeping things modular actually keeps things flexible.
Right. And today we'll walk through a small example showing how all those pieces come together.
Okay, now that we know why Fusion uses multiple cards, what exactly are we installing today?
We're keeping it simple: one detected block, one signal mast, and one turnout. Each has a dedicated Fusion card and a matching breakout board. They all plug into the hub, and the node card ties everything together.
So, detection, a signal, and a turnout. 3 examples to show how the pieces work together.
Exactly. It's a clean, realistic install that shows the whole pattern without overwhelming things.
Alright, we've got detection, a signal, and a turnout in our example. How do these actually connect together?
It all starts with the node card plugged into the hub. The hub gives every card power, CAN bus, and the I2C lines. Each card just drops into the hub: the detection card, the signal card, and the turnout card. No wiring between the cards.
So the hub is like a motherboard, and the cards plug in like expansion cards?
Exactly. Then each card connects to its breakout board with a network cable. The breakout sits right under the layout where the device is: the track block, the signal mast, or the turnout machine. That keeps all the wiring short and clean.
Makes sense. So instead of dragging wires across the layout, you just run one cable to a breakout next to the hardware.
Right. It keeps the installation modular, predictable, and easy to expand.
Okay, the hardware is plugged in. What happens next? Do we have to configure each of these cards separately?
No, that's the nice part. All the configuration happens on the node card. The other cards don't have logic and they don't need it. They just provide hardware, inputs, outputs, or a detection reading, and the node card handles everything else.
So the node card is the one place we configure the whole setup.
Exactly. And most of the CDI settings already have safe defaults. You usually only change labels, addresses, or media behavior option if you want something specific. Everything else can stay right where it is.
So configuration isn't 10 pages of tweaking, it's more like reviewing a checklist and moving on.
Right. The node card automatically identifies the cards you've installed, and the defaults get you most of the way there.
So do we always need logic? Every time we hook something up, do we have to write rules for it?
Not at all. A lot of things work without logic. If you have a button that simply turns something on or off, the CDI can map that directly. Press the button, send the on event. Release it, send the off event. An output card is configured to simply turn on off an LED based on these 2 events. No logic required.
So for basic control, the CDI handles it automatically. No conditions, no rules, just a direct connection.
Exactly. Logic only comes in when you need conditions. Signals are the best example. You don't want a signal turning green just because a button was pressed. It needs to look at what's happening on the layout.
So simple devices? No logic, Smarter reactions? Add logic. Got it.
Right. Fusion gives you both simple CDI wiring for the easy stuff and logic only when the situation actually calls for it.
Okay, so logic isn't always needed. But when do we actually need it?
You need to configure logic when the behavior depends on a condition. Signals are the classic example. A signal can't just show any aspect at any time, it needs to respond to what's happening on the layout. Is the block ahead occupied? Is the route set? Those are conditions.
So logic comes in when something has to think before it reacts.
Exactly. And logic lives only in the node card. It listens for an event, like the block becoming occupied, and then sends the event that updates the signal mast. The rules are small sentences. When this happens, do that.
That sounds easy enough. Not programming, just describing the behavior.
Right. And you'll see how simple it can be when we walk through the signal example next.
Alright, can you walk me through one complete example? Like, from the track block all the way to the signal changing?
Sure. It starts with the BOD Breakout Board. That's the small board mounted under the layout next to the rails. It senses the current in that block and passes it to the BOD card.
So the breakout handles the wiring to the block's rail by connecting to its drop line. The card handles the electronics.
Exactly. The BOD card reports the status to the node card using the node bus I2C communications connection. The node card looks at that line status and decides whether the block is occupied or clear.
And that's where the logic comes in.
Right. Your CDI logic says something like, when the block becomes occupied, set the mast to stop. When it becomes clear, set the mast back to clear. The node card controls that aspect change using the PWM card, and the signal breakout board lights the LEDs on the mast.
So the whole chain is block node logic signal.
Exactly. One simple example that shows how the entire Fusion system works together.
Okay, that one example makes sense. But what if someone wants more than one block? Or a whole set of signals?
You just add more cards of the same type. More blocks. Add up to 16 BOD cards supporting a total of 64 blocks. More signals. Add up to 16 PWM cards supporting up to 256 signal lamps. More turnouts. Add up to 16 turnout cards supporting up to 128 turnouts. Everything plugs into the same hub, which can be connected together as your cluster scales. Each card still gets its own breakout board under the layout.
So to grow the layout, you don't redesign anything. You just add more pieces.
Exactly. The pattern never changes, each new device gets its own card and its own breakout, and the node card ties everything together. It keeps expansion predictable and keeps the wiring clean.
So Fusion grows horizontally, just adding more modules, instead of stacking everything onto one big board.
Right. It's like adding new expansion cards to a computer. Same slots, same connectors, same workflow.
Alright, so the hardware scales by adding more cards. But what about the logic? Does that start to get messy when the layout grows?
Not really. Logic grows the same way the hardware does, horizontally. If you add more blocks or more signals, you just add more logic lines. Each one is the same simple pattern. When this happens, do that.
So it doesn't get deeper or harder. It just gets longer.
Exactly. And the node card only reacts when something changes. If one block becomes occupied, the node card only touches the logic tied to that block. All the other lines just sit quietly until they're needed.
So even with lots of blocks and lots of signals, the system stays responsive because it's only looking at what changed.
Right. No changing software or scanning a giant list, just reacting to events. That's why Fusion can scale across a whole layout without getting bogged down.
Up to now, the logic has been pretty simple. But when does it actually get more complicated?
Usually when a signal needs to look at more than one thing. A distant signal might need to check both the next block, and maybe the one after that, before choosing the right aspect.
So the signal needs a bigger picture than just the nearest block.
Exactly. And turnouts add another layer. A signal may need to know whether the points are line straight or diverging before it decides which aspect to show.
Okay, so occupancy plus turnout position. That's already two conditions.
Right. And if you have an interlocking, where multiple routes overlap, the logic might need to combine block status, turnout alignment, and any opposing movements. But even then, they're still the same readable rules. Just more of them.
So the rules get richer, but they stay understandable. The node card just checks more things before making a decision.
Exactly. The complexity is in the conditions, not in the system. We'll do another podcast just on configuring logics.
Alright, we've covered hardware, breakouts, CDI, logic, signals. What does the whole installation actually look like from start to finish?
It's surprisingly quick. You plug the 4 cards into the hub, a node card, a BOD card, a signal PWM card, a turnout card. Then you mount each breakout board right under the layout next to the device it serves. One network cable per card connects everything neatly.
So physical installation is basically just cards in the hub, breakouts near the hardware.
Exactly. Then you open the node card CDI. Most of the settings you'll simply accept as is, because the defaults already do the right thing. You just add the couple of logic lines you need. When the block goes occupied, set the signal to stop. When it clears, set it back to clear.
So the configuration stage is really just describing what should happen, not programming anything.
Right. Once you save the CDI, the whole system just runs. Detection reports occupancy, the node card reacts, and the signal updates instantly.
That's a clean installation. Cards in, breakouts wired, defaults accepted, logic added. Done.
Exactly. And the beauty is that the same pattern works whether you have one block and one signal or an entire division.
So that's the whole install, from hardware in the hub to the signal changing on the mast. What's the big takeaway here?
The big idea is that Fusion stays modular. Each card does one job: detection, signals, turnouts, and the node card ties them all together. All the configuration and logic live in one place, and the breakout boards keep the wiring simple under the layout.
So whether you're setting up a single block and a signal or expanding across a whole basement, the pattern never changes.
Exactly. Install the cards, connect the breakouts, accept the CDI defaults, add the logic you need, and the whole system runs automatically. It's straightforward, scalable, and easy to expand whenever you want.
Perfect. A simple example, but a complete one. Minimal time under the layout wiring, I like that. Great place to wrap up. Stay tuned for additional podcasts on configuration.